Okay, we're continuing with Math 1010 Intermediate Algebra, Module 5, Review. This is Lesson 2. The first objective is to add or subtract rational expressions with like denominators. So here we have x plus 15 denominator and this, z plus 15 denominator. So the basic rule is a over c plus b over c is a plus b all over c. So the common denominators, when they're separate fraction forms, you see them twice. When we add them together, there's just one. So in this problem, we'll just have a z plus 15 in the denominator. And now in the numerator, we just add the numerators together. Okay, there's some like terms in the numerator. 15 and 3 is 18, z. Minus 19 plus 12 is minus 7. And the z plus 15. And that is the result of adding these expressions that have like denominators. Okay, great. Example 2. Again, we're, in this case, subtracting rational expressions, and they have a common denominator. So the denominator will be common to both, and the numerators, we need to be careful with the subtraction. I'm actually going to introduce a parenthesis around that numerator. So we have 2x plus 10 minus parenthesis x plus 5. That parenthesis helps us to correctly distribute this negative sign. The result of that will be minus x minus 5, denominator. Okay, and now simplify a little more in the numerator. That is x and plus 5. Now the denominator might factor and simplify, so let's try it. X and x, sure enough, plus 5 and plus 1. So often when you add fractions together, the result can be simplified. So we can reduce, and what's left is 1. That's a factor of 1. So our final answer is 1 over x plus 1. Okay. Next objective. Find the least common multiple of a pair of polynomials. So essentially, you have to first look at the prime factorization. So 3 and 5 and a and 5 b's. And you don't necessarily have to write them all separate, but this first time I am. Okay, and the other one, 9, which is 3 and 3, and 2 a's and 1 b. Okay, so creating the least common multiple, each factor, well, expression, it was, each term, I should say. Each term gives every factor that it has. So this has a 3 and a 5, so our answer has a 3 and a 5 and an a and 5 b's. Now the next one has 2 3's. Now one 3's already contributed, but the next one can contribute the extra 3 and an extra a. So now, looking at this expression, this first term can see itself reflected in it, and the second term can see itself reflected in it. This is the least common multiple. That is 9 and 5, 45, a and a squared, b to the 5th. Of course, the answer in the back won't have the time symbols. Okay, next example. We have m squared minus 2m and m squared minus 8m plus 12. Factoring, greatest common factor first. And 6 and 2 minus 6 minus 2. Oops, I did an x. Okay, so the first one can contribute an m and an m minus 2. It now sees itself reflected in the the least common multiple. The m-6 can be contributed, and then the m-2 is already there. So the second one can also see itself reflected in this answer. This is the least common multiple. All right, next objective. Simplify a function involving rational terms with like denominators. All right. So f of x equals like denominators. We can just copy down the like denominator. Oh, that should be a 2. So, all right. There we go. And the numerator, we have x minus 1. And this subtraction, again, a parenthesis, will allow you to do that more safely in 2 steps. This next step, x minus 1 minus 2x minus 15, denominator x to the 4th. Ha! Wow, I got to slow down a little bit. Happily, I've got an eraser. X squared plus 4x minus 32. We can reduce an x, so that is minus x and minus 16. And because of this 32 might have a 16 in it, we can factor it just to see. So we have x, 8 and 4 is what does it though. X plus 8, x minus 4. Nothing reduces. So whether you want to write it that way or you want to write it without the factoring done, both answers are simplified. So either answer is fine. But in order to know that it's simplified, you do need to try to simplify it. So since you try to simplify it, you should get this far, and that's fine if you write your answer like that. All right, let's look at the next example. Again, like denominators. These are the easy ones. Because when there's like denominators, you can just combine and get, let's see, 3x plus 11. Ooh, there's a subtract. So subtract parentheses. It's just a really good step to give you a chance to distribute that negative easily instead of trying to do it all in your head. That's where I make my mistakes, is when I do that. Okay, now the x squared minus 25 is begging me to factor x plus 5x minus 5. But because it's such an easy one, I know what it is. Let's see. Numerator, x plus 12. That's not an x plus 5 or an x minus 5. So because I know how this factors, I know it won't reduce. Okay. Now, often when you're given a function and asked you to simplify, they often extend and say, list restrictions on the domain. And then it really would be nice to have this denominator factored so you can see x cannot equal 5 or negative 5. But they're not asking for it in these few examples for this objective. All right, next objective. Add or subtract rational expressions with unlike denominators. Now this is where we have to get to a common denominator so that we can then add it like the previous problems easily. So let's start with factoring. That's our first one, minus. One trick, it's not really a trick, but this subtraction can cause problems. You can change it so that it's plus, and the numerator, negative 5. Puts the negative a little closer to the action that's going to be there. Let's see, that's x plus 4x plus 1. Okay, now what we see, first off, oops, that didn't work. I'm trying to make a, nope, it's not going to work. Okay, fine. We need a common denominator. Okay, so x plus 4, x minus 4, x plus 4, x plus 1. This one needs the x plus 1. So we're going to give it an x plus 1. And this one needs the x minus 4. So now we're multiplying by a factor of 1, which does not change the value of the expression. It's still an equivalent expression. And now you can see that they have common denominators. So since they have common denominators, what we can do is now add them together with the common denominator as their common denominator. Sorry, that's pretty amazing English there. Okay, and here I'm going to write this step down just because I know people make a lot of mistakes right here and I want to point it out. What I want to point out is because of this subtraction, this numerator is two separate terms, so it's one big ugly factor. So unless you see another one of exactly those in the denominator, which I don't, you cannot reduce anything. Don't be canceling out these or the, that's wrong. Instead, you simplify the numerator. This might reduce, but you have to get it to a point where you can reduce it. We don't even know what the numerator is yet, let alone what it's equivalent to. Okay. Great. Equals, now the numerator, to save me a little bit of work, rewriting it, I can factor this. 5 and 4 won't work. 10 and 2 won't work. 20 and 1 doesn't work. That's actually it. It doesn't factor, so I can't reduce. So our final answer a little bit uglier, but we have successfully added, or in this case subtracted, these expressions. Now I'm hammering over subtraction over and over and over. If it's addition, you just don't need to do that distribution with the negative. It's one step less. But so far this review hasn't had any actual addition. There we have some additions coming up. Okay, good. Now example 2. Adding these together. First off, I want to see what their denominators look like. That will be x minus 2 and x minus 3 plus negative 28 instead of minus 28, and that is x minus 2, x minus 4. Okay, so this first one needs the x minus 4. And the second one needs the x minus 3. And now we have common denominators. So the result of that is x minus 2, x minus 3, x minus 4, common denominator. Now I'm going to distribute these. This is a one step that you can pretty safely do without making mistakes, and it also eliminates the previous examples temptation to reduce where you can't. Here we have to distribute the minus 28, so that's minus 28x plus 84. So reducing or simplifying the numerator, 7x squared minus 56x plus 84. Denominator has not changed. Now the numerator may reduce, so we have to try factoring it. First off, x squared minus 8x plus 12, and I'm just going to write LCD for a minute. So we can factor the numerator now. That will be x minus 6 and x minus 2. Now I can recall the LCD. Okay, and sure enough it reduces. You have to try, or else you don't necessarily know that you have a simplified answer. In this case it reduces. So our final answer is that one. All right, looking good. Example 3. Okay, I'm going to do the first step, which is factoring the denominator. Now this one is out of order. So we have y and then number. This one's y's and then number. This one's number and then y. So I'm actually going to factor out a -1 to switch that around. Now it's in order. And that minus can turn this into a subtraction, or that negative can jump up to the top. It doesn't really matter. We'll deal with that next step. And now this is a difference of squares. It is 3y plus 5 and 3y minus 5. So we see our common denominator. 3y plus 5, 3y minus 5, that's what it is. So this one, I can go in and give it what it needs. This one needs the 3y minus 5. This one needs the 3y plus 5. This one has everything it needs. Okay. So we have, now I want to distribute that through. So that's minus 3y squared plus 5y. And I want to distribute all of that stuff. So that's minus 12y squared minus 20y. And our little plus 5 float over there. Let's reduce and see what we get. I'll just double check where we're at. Looking good. Okay. I have a key in front of me so I can catch mistakes, because I, like everyone else around, are human and make mistakes. I don't want to be showing them to you. Negative 15y squared minus 15y. Actually, I don't mind showing you mistakes if I can then demonstrate how I recover from them, because that's one of the keys to success in math, is recovering from the mistakes that are invariably made. All right, now, once again, I have to see if I can reduce. So I need to factor the numerator. And it looks like I can factor a -5 out, leaving us y, all right, 3, see, there's a mistake, 3y squared plus 3y minus 1. Would that factor further? 1 and 1, 3y, y. No. It doesn't factor any further. Oops, come on. So, we tried. You have to try to know whether it reduces. So we tried to factor, it doesn't go any further, no factors of 1 to reduce. That's it for problem example 3. Okay, the fifth objective of this second lesson of Module 5. So this function has unlike denominators, and we're trying to add and subtract it to simplify. So the first thing we need to do, I'm going to put this 9 over 1. I'll give myself a little space to work this time. I'm going to do the minus 200 on top. Don't know if I need it yet. This denominator factors. All right. So that gives us our common denominators. I can see that the common denominator will be the x plus 10 and the x minus 10. So that informs me as to what I need to multiply by. This one, I need all of it. I need the x plus 10 and the x minus 10. Whereas this one, I just need the x plus 10. And this doesn't need anything. All right, great. Let's see what we get now. So this is going to take some steps to distribute. I want to do them right here. I know that's x squared minus 100. So now I can distribute the 9 through, getting 9x squared minus 900. plus x squared plus 10x minus 200. Okay? So this is 9x squared plus x squared, 10x squared plus 10x minus 1100 over our x plus 10 and our x minus 10. And we can factor the numerator, and we have to see if we can reduce. So factoring the numerator leaves us x squared plus x minus 110 over x plus 10, x minus 10. Continuing on, factoring further, we can't factor this one. I don't know if it'll work usefully yet, but it does factor as 11 and 10, and a plus x, so plus 11 minus 10. All right, so I am glad that I tried to factor this one because it reduces. Okay, commonly on a question where there's functions, they would, so this is the answer, they would also tack on what are the exceptions to the domain. And even though this reduced, it doesn't take away from the fact that 10 is still an exception, because the original problem, 10 is clearly a problem. So if you reduce and something cancels like this, that does not change the restrictions on the domain. So if they add that into the question, just make sure that after you factor everything, from that point you can see the 10, the minus 10 are problems. That's where you grab the restrictions, long before you do any reductions. All right, that's example 1. And that completes that lesson. Okay, great.